Hello friends, welcome back. Today we're going to use the reduce method to analyze data. Array.prototype.reduce, or simply reduce, is the most general of all array operations in JavaScript. You can solve almost any array processing problem using the reduce method. The reduce method allows for more general forms of array processing, and it's possible to show that both filter and map can be derived as special applications of reduce. The reduce method iterates over each item in an array and returns a single value. Example, the string number object array. This is achieved via a callback function that is called on each iteration. The callback function accepts 4 arguments. The first argument is known as the accumulator, which gets assigned the return value of the callback function from the previous iteration. Which gets assigned the return value of the callback function from the previous iteration. The second is the current element being processed. The third is the index of the element, and the fourth is the array upon which reduce is called. Okay, so we might go back to this because this is really important. And it's also, when you first read that, that's probably impossible to understand. In addition to the callback function, reduce has an additional parameter which takes an initial value for the accumulator. If the second parameter is not used, then the first iteration is skipped and the second iteration gets passed the first element of the array as the accumulator. Again, this is useful to understand. It's very important to understand, but it's probably difficult to understand just from that description. See below for an example using reduce on the user's array to return the sum of all the user's ages. For simplicity, the example only uses the first and second arguments. So for simplicity, they're just using the first argument. So they're using the accumulator, and they're using the current element. So the accumulator, so the sum is... I guess they're starting, so they're creating a thing of sum, and then they're doing a user for each element in there. So each user, so each time we come this. So user.age, so sum is plus or equal to user.age, and then they're 0, which is, and the second element, the third element is the index of that element, and the fourth is the array upon which. So there's not a fourth one being called here. No, wait, that's not right. Comma 0. I'm not really quite understanding. So here's another example to see how the object works. The users were users.reduce, the object and the user. We're being passed in the accumulator and then the user object. We return that, and then the last one we're returning a object. So the variable watch list holds an array of objects with information on several movies. We want to use the reduce function to find the average IMDb rating of the movies directed by Christopher Nolan. Recall the prior challenge how to filter data and map over it to pull what you need. You may need to create other variables and return the average rating from the getRating function. Note that the rating values are saved as strings in the object and need to be converted into numbers before they are used in any mathematical operations. Okay, great. Let's go to the top. Look at this. Here's the watch list. It's got a list of movies in it, just like we've seen before. We've got our average rating. Okay, so I'm just going to keep this average rating to the side for now. Let's start by figuring out I like using let. Let's let Nolan movies equal to the watch list and dot filter. So the first thing we're going to do is filter out all the movies that aren't Nolan movies. So we want to filter based on the movie. And again, I'm going to do this in old school JavaScript, and then I'm going to refactor at the end of the video to use ES6 arrow functions. And so we want to filter the movie, right? So we want to say if movie dot director movie dot director is equal to Christopher Nolan, we want to return the movie. Cool. Okay, so now if we return Nolan movies, we're going to have a list of Christopher Nolan, movies, Christopher Nolan, Christopher Nolan. We should only have Christopher Nolan. Okay, so now we have a list of Nolan movies. This is helpful because we could also go, now we want to let Nolan movie count equal Nolan movies dot length. And if we were to go Nolan movie count, we've got 4. So there's 4 movies by Christopher Nolan supposedly in here. Okay, so Avatar wasn't included in there. There's 1 from Nolan. There's 2. There's 3. There's 4. Okay, so there's 4. Yeah, so Nolan movie count is working. So now we really need is, well, we could say this is going to be equal to a number divided by the Nolan movie count. And so we can keep this as, what was it? Yeah, the average rating. So this way we're not changing the code below this line. So average rating, okay. The average rating is going to be whatever divided, so the sum of all the Nolan movies. Let's put Nolan movies back in here for now, just so we can see. Well, the next thing we want to do is, yeah, we should just reduce the Nolan movies. So, yeah, we'll let the sum Nolan movie sum or rating sum is equal to Nolan movies dot reduce, and in here we're going to add we're going to start a function with the total and the movie. And here we're going to, because it's a reduce function, I brought this up here. This is the JavaScript. This is how they actually teach it. So you want to do a function with the total, current index, and array. For this, you don't need to pass in these, and since we're not going to use them, we're not going to put them in there. But we could if we wanted to. The total, the movie, the current index, and the array. We don't need them, but I'll refactor the code later. So for now, I'm just going to take the total, the current, we've got a function, and then the initial value. We want our sum, we want to start with an initial value of 0. And what we want to do is take the sum, or the result, is equal to, we want to let the result equal the, no. We can just go total plus equal the movie dot IMDb rating, and we're going to say parse float. So we're taking the string and turning it into a number, and then we want to return the total. Okay, so now let's put Nolan movie sum into here so we see what's going on. 34.7. That's the rating. Okay, so that I think is correct. Yeah. So this is the sum of his ratings, and this is his count. Okay, so let's change this back to average rating, and then we want to let average rating be equal to the Nolan movie rating sum divided by the Nolan movie count, because the sum divided by the count is equal to the average. So the average rating is equal to that. And there you go. I think that that's the right answer. Okay, and I just, so yeah, let's run the test and see if they pass. Awesome, it passes. Okay, cool. Before we move on though, I'd like to kind of go back through and think about this We can change these to arrow functions and clean up our code, right? So this would be a way, this would work the exact same way. As long as we keep getting this 8.65, our refactoring has been successful. With this if statement, there's no real reason not to just put this on one line here, because that just makes it look a little bit cleaner. And I think it makes more sense this way. Nolan movie rating sum is equal to the dot reduce. Okay, well, we could use arrow functions here as well. And it doesn't make much of a difference there. Now, we use the parameters total and movie, but we don't need the current index or the original array because we're not using them. And we'll run into places where we use those in reduce, but we don't need those now. So we can factor that back and make our result look even better. Now, I actually like the way the Nolan movie count is created after we've got the Nolan movies because, we actually need to have the Nolan movies here. We need to have all the movies that he has. One thing that you could do is you could do map and then just take all the objects from there, and that might be a quicker way to do it. But why? Nolan, the number of movies that he's going to make there's only so many movies that are going to fall under this category. So why not? Even if somebody's a super prolific movie maker and they made 1,000 movies, it's still going to be too small programmatically for it to be expensive to calculate. So I don't see why we would want to do anything else to that thing. I mean, here, first off, we're iterating through the whole watch list. And so if the watch list was huge, this would take a while. But at the end of the day, there's not really anything that we can do to stop that. So then once we get this, we're going to have the small number that we're going to reduce from, where we add to the total and we do the float. Yeah, we just add each of the sums of the movies, right? So the IMDb rating was 8.6 here, and then here the IMDb rating was 9.0. And so we just added all of those together and we returned the total, and we started at 0. That's how reduce works. And then, so now we've got the count, and then we've got the sum. So sum divided by count is average, so average rating. And because of the nature of this, I would say get Nolan movie rating. Get Nolan. This I would say, if I were refactoring this for real, I would say get Nolan directed movie rating average. Some people don't like this, and they think that this is a sign of bad code, but I disagree. I think that saying get Nolan directed movie rating average is better than just misnaming the function. And so the watch list is here, and then we get the Nolan movie. I'm not sure if that'll break the test. That does break the test, probably because of Free Code Camp just has the setting there. So we don't want to refactor this because that causes it. So we can't solve the test, but that's how I would refactor this if I were doing this in production code. And I don't really see any other opportunities. We want to just be able to quickly count there. I mean, we could, instead of we could just do this. That would be a way to make our code a little bit shorter. And I think that that's pretty readable. And anybody who knows programming is going to know how to do a dot length on the movies. And so we've got Nolan movies specifically laid out. And then the sum, we can't get this any easier than that. But I do think it's smart to have the average rating and show how we get that by having a count by summing up the averages, and then by summing up the ratings, and then we divide that by the length of the movies. So how many movies are in there. And so, I think that this is a pretty smart way to refactor this down. And so if we run the test, it passes. Hope you guys enjoyed this one. We'll see you in the next lesson.